Hello and welcome to another episode of Beyond the Grid. We're going to talk a little bit about not just the power grid, surrounding technologies, specifically AI. AI is the talk of the town. It is now finding its way into the heart of some of our most critical systems, be it power grids, energy markets, data centers, and other industrial infrastructure. And my guest today is someone who has spent quite a bit of time in this space, particularly the intersection of AI and energy systems. Wish Bakshi. Vish is an AI systems engineer, entrepreneur, and educator. He works at the intersection of AI, energy systems, and large scale infrastructure. He's built real world AI systems for power plants, load forecasting, commodities trading, and other decision making tools. But he's not just building systems, he's also teaching others about the future of AI. And he's almost like an evangelist when it comes to the industry. So we'll talk a little bit, go a bit beyond the hype and talk about what it actually takes to deploy AI in mission critical systems. And yeah, I'm looking forward to this conversation today. Vish, welcome to the podcast.
No, thank you. Thank you, Rahul. Wish more and more people were doing this, the real good stuff of getting the word out. And just like myself, you have a very, very similar background. So this is going to be an exciting conversation.
Excellent. Why don't we get started? Talk for the listeners, talk us through how you describe what you do today at this intersection of this critical pieces of systems.
Yeah, I mean, there are really, really smarter people than myself who are at the intersection of kind of building the models, right? So whether that's power, that's gas, that's trading, and even NGLs. So one is on the commercial side. Then the other one is in the operation side, which is the physical assets that people have to maintain and sustain. And, these assets in the energy field, they're worth billions and they have immense life cycles and they burn a lot of fuel and the OpEx on these things are immense. So if you can optimize 1 or 2% of these physical assets, and also if you're a trader and you have a book size of, let's just say $100 million or $50 million, doesn't matter, and you optimize that by 1 or 2%, Q over Q using AI, that has a compounding effect. And so my job is about 95 or 90% of the projects across the entire energy value chain fail. And it's not because the models don't work. The models actually work really well. It's that last mile problem of configuring it so that these things can sustain themselves and thrive in the ecosystem so that these models can go and build the next model. So my job is basically kind of being the bridge between the commercial units, the SMEs, who are trying to build something, but they don't know where to start. And then obviously when they do get started, how do you scale these systems? And that's kind of like what the AI systems engineer role is to kind of come in and work with all the hyperscaler technologies, work with having the depth in the energy field as well, and bridging those gaps to kind of solve that last mile problem.
How did you get started with this? Like, you have a very interesting background. I know you did spend some time at Capital Power as a commodities trader, if I'm not mistaken, right? So then from that to being the outspoken evangelist for AI, what was that journey like, and how did it come about?
I got lucky. Swaroop, I honestly feel like, people ask me this question and I had immense sponsorship and I got lucky. I got to work with the commodities traders. So I worked with power and gas folks and really I was seconded into these units from the ITIS group. One of the executives there has become a very close friend of mine, actually two or three of them. And so they kind of believed in the AI hype almost like 10 years ago.
Uh-huh.
And they were willing to experiment back then. And what happened was everything was greenfield, right? And so people didn't know what AI was, but they kind of heard about machine learning and analytics. And so they opened a lot of doors for me. And I got seconded first on the operations side. So I learned a lot about how these physical assets work. And to do that, you have to work with hard hats, right?
Yeah.
Who understand how the grid works. That's where you learn about frequency, inertia, harmonics, voltage, everything that matters that, unless you're in the weeds of it or you're electrical engineer, you're not going to learn it, right? And so once I learned that, I then configured those systems to kind of go up and connect with the cloud. So it was all greenfield, net near. And then once I delivered on that side, then, we built it on the commodities trading side. And this was just not the company over there. It just kind of like evolved over time. And that's where my journey kind of got lucky because a lot of the executives and the decision makers sponsored me and said, hey, listen, like, why don't we take some risk over here? And one door led to another door, another door. Only criteria that I would ever anchor myself on is like, you got to deliver. That's the only metric, right? And once you deliver, everything just follows through. And then obviously, like, what really helped and be completely transparent is that having a technical background, right? So having a background in computer, like I have 4 degrees, computer science, statistics, quantitative economics, and a master's in AI from Queens as well in analytics and AI. That all kind of adds up. So when you have the core competency of the first principles, but then the right people and the right sponsors open up a lot of doors for you, and all you got to do is now build the thing. I mean, a lot of things kind of worked out in my favor.
And technology coming along too, right? 10 years ago, the AI that we know 10 years ago is no longer the AI that we know right now. The biggest shift is obviously generative AI, but there's much more beyond that, right? I mean, I think when I say the biggest shift, what people latch onto mostly is generative AI because it's so interactional. But beyond machine learning, we have advanced so much. What are some of the more interesting things that you're doing right now? Some interesting projects that you can share with us, like what
Oh yeah, yeah,
interesting problems?
yeah. I got to be a little bit careful how double click I go into it, but
Well, I completely understand.
no, no, you
Yes.
got it.
Yes.
So, I mean, everybody knows, right? Like power and gas and molecules, they're a hot commodity now,
Yeah.
literally. And so my job actually is to basically, there's a lot going on, but you have like these massive facilities like LNG facilities, you have power plants, and then you have AI data centers. And they have two components. They have the commercial side and the operation side, like we discussed before. So my job is to basically say, hey, listen, how do we merge these two domains in terms of risk appetite? And that comes under two categories: performance optimization and then P&L. Those are the two metrics, right? Profit and loss. So my role right now is I spend half my time in the US and half in Canada. And what I'm doing now is building these systems that basically integrate and then provide insights. Now, I got to be careful here because a lot of people think, oh, you're doing automation, right? Because that's the biggest common misconception about AI. No. What we're doing is we're doing augmentation, which is saying, hey, listen, before, for as an example, like we're working with like SCADA tags, right? On
Uh-huh.
systems. Before you could only look at 10 sensors or 20 sensors because that's the throughput of a person that's sitting there physically looking at the ICS. What AI is able to do in the systems that we're building now is basically they configures, connects to it, pulls the data, and gives them insights on sensors that they didn't have the ability to like check before, right? That's one. And then the second one is obviously market intelligence, which is like there's so many announcements, there's so much data coming in through like, your power consumption, your load profiles, gas. And so the idea over here is how do you enable the marketers and the trading groups to have real-time insights so they can actually manage their positions pretty actively. And the third one is actually like pretty new now in this industry from a perspective of like real time, but is outages. And so today, for example, if you have a CCGT, like a combined cycle power plant with a 7 heat rate or something like that, it's burning about 150 MMCF of gas per day. Right? Generally speaking, these things didn't have to ramp up and down the way they're expected to now for these AI data center loads that are coming in. So the fundamentals of how you built your risk profile and then you manage that risk profile, because how do you manage if a power plant trips offline and you are fully contracted to deliver electrons to an AI data center that's coming online? And you're
Yeah.
seeing this play out in Texas and PJM quite a bit. And so my job is to basically build these models that allows them to like quickly get these insights so that they can be less reactive and more like prognostic or prescriptive. And then, sorry, last one I'm doing now is like programming a lot of the NVIDIA chips for load profiling. Essentially, like, these NVIDIA GPUs are coming in, GB200, GB300s, and then Rubins come out. And then that's going to be the next year. So these racks densities are increasing exponentially, not exponentially, but linearly they're going up. So current rack size is about 130 kilowatt. Next ones that come out are about 600. And so that's almost a megawatt per rack. Just think about that,
Yeah.
right? And so how do you model your power, your gas exposures when these racks are coming in? And then what are your break evens, right? From an application standpoint. So doing a little bit of that as well now.
Got you. Interesting. Just you mentioned something about ensuring gas supply and making sure that that gas supply feeds then into power generation and you have consistent power supply into the data centers, right? What's a model that's showing up more now? So one way to think about this is build generation close enough for just the power that is needed for the data center, right? Almost always doesn't work out. The other way to think about it is like I overbuild the generation so that I have sufficient and more. Or there could be a deeper partnership with the grid, right? But if the deeper partnership with the grid is not managed, planned well enough, then you're going to be stressing the reliability of the grid as well. What are you seeing in terms of where people are moving towards?
So it goes through phases. I mean, it's such an intuitive question, right? Because everybody's still trying to figure this out on the fly, right?
Exactly. Yeah.
And so nobody knows what the right model is. And just for the listeners, right? Just to give you some perspective, there's about like data centers in the US is probably going to take about 6 to 12% of all US energy use by 2028. So that's just like 2 years from now, assuming all the gen comes in and the transformers show up, right?
Exactly.
That's about 255 terawatt hours, I think, of energy. Roughly, if you just translate that, that's about 25 million households. So that's just shy of Canada's population. That's how much energy it's going to take on a per day basis. Now, to answer your question from a perspective of what you're seeing, well, it depends on where these AI data centers are going. So if you go to PJM, which is about 65 to 70 million households that serves, then you have Virginia, which is the data center alley. Now, over there, they have a different problem is that they can't get enough two things, gas transmission, and they also can. And then Dominion is another domain, right? Like that serves, I think, 300 data centers as well. They are trying to figure out, well, do we bring BYOG, bring your own gen, right? Now, the problem is if you bring a BYOG gen, you have to do an overbuild because your redundancies have to be very high.
Exactly.
So now you're talking about, well, how do I get gas over there? Then you talk about, well, okay, they trip. So do you bring diesel or do you bring BES? And then if you want to bring BES, well, how long are the durations? Average duration is 2 hours. You can go up to 4. Capital intensity increases. Now, even despite that, right? Like, here's a very good example. I think just like last week or something like that, you had an outage in Coastal Gas or Transco. I can't remember. So about 400 mmcf of gas has disappeared, right? No, it hasn't come online still. And so now if you were behind bring your own gen and that outage had happened, well, your batteries are not going to sustain you, right? And your diesel is going to run out pretty eventually. So how do you hedge that risk? I mean, BYOG is bring your own gen is probably, the trend right now, but people are quickly realizing in ERCOT, for example, in Texas, that might cause different problems because ERCOT has only so much takeaway capacity for
Yeah. Yeah.
new pipelines for gas that are coming on. And most of them are procured for LNG going out of the USGC, right? And so now people are kind of doing the math and being like, well, there's a lot of risk on the profile now. So that's the trend right now.
Yeah. But what do you think? BYOG isn't it because um utilities have not woken up to the challenges and more importantly the opportunities ahead of them? Isn't BYOG for me is not an optimal model, right? Because you're very focused on one small problem rather than thinking about a macro solution. Aren't utilities missing the bus a little bit? What do you think in the US? What's happening?
I think so. I definitely think so that they're missing the bus. The problem is that they look at PJM, right? They have their capacity auction right now. I think they're at about 350 and they put a cap on there because Governor Shapiro from Pennsylvania is like, saying you're going to quit the PJM grid, right? For example. And so if you look at that, if without the cap, I think that the number I saw was like about $500. Now, the problem is the incentives for new gen for utilities to build has been disconnected only because you put a cap, right? That creates a second problem, which is that a lot of the older units that were going to be in the merit are actually going to be saying, well, I'm just going to mothball myself because that $300 or 350 is not juicy enough for me.
Yeah.
So
Yeah.
utilities are missing the bus, but that's more like depends on which ISO you're in. And how are they playing it out, right? Because in ERCOT, they're just like, build. I don't care. Just go for it, right? But then that's creating like different things, which is like clusters, right? Like you're going to the west side and they're trying to power through gas. But this is also why OpenAI and Oracle and all the big players, they're all building it over there because they can build it faster. And utilities are definitely missing out on that.
Is Canada missing out significantly compared to the US?
100%. There's no doubt about it, right? Because there's only so much inventory to go around.
Yeah.
And I think, I mean, it's a sensitive topic and you have to be careful how you answer this. But, we do have a very big advantage on the gas side, which is the ACO spread, right? The ACO basis. I think ACO is about $2 right now. It was negative at some point in December as well. Henry Hub is about, I think 350, maybe even 4. I haven't checked as of last week. It's very volatile. if you're saving about 200% on eco from that perspective, there's every incentive for these AI data centers to come here. Now, that being said, the carbon tax and those things add up. That's all I got to say about that. So there is a bigger play here, but they got to remove the red tape because, and then here's another thing too, right? Down in the US, they build very quickly, man. Like,
Yeah.
when I'm down in Texas, they're building like nothing. And I do significant rotations there. And there's just like, we got to build a pipe. Yep, go for it. We got to build a best siting, go for it. And the capital intensity is very intense over there too, because they're able to build quite quickly. Now, I think Canada's a little bit of a different story for different reasons, but I'm going to digress from that. I'm not getting to why that might be the
Yeah,
case.
yeah, no, complete something else like sustainability, environmental considerations. Not that is big in the radar right now with the current administration, but what's your opinion? Because you've definitely seen pushback from at least some portions of the society. There's some communities outright saying that we don't want this in our community. I've seen case studies where it's showing that it's increasing the cost to consumers, right? Average power cost to consumers,
Mhm.
impacts to water, things of that sort. So what's your sense there?
No, I don't think, I would say it depends on what your global perspective is, right? If
Mm-hmm.
if these are your paramount goals, which is ratepayer, and these are all valid points, like impact to ratepayers, ESG, on all these mandates. But the counterpoint to that is China doesn't care about any of that, right? And so it depends on from a macro perspective, where do you want to put your eggs? Because there's a very famous chart that gets circulated around what China's doing, which is like solar is ramping up, batteries ramping at record. I think they put as much solar new builds out in a single quarter as France has in the entire region. And that's saying a lot, right? I mean, now keep in mind, France is nuclear. China has a lot of renewable as part of its growing segment. So it's not a one to
Sure,
one mapping, but they're also building a ton of coal plants.
they do. Yeah,
So, I mean, it's insane. So if you're trying to figure this out, I would just say, like, where do you want China to take over on the new, because they're just blowing us out of the water, right? In new bills for
sure.
power. Whereas with US, if you want to start controlling this, but then you can't have your AI victory story either, right? So there's a bigger play there. From my perspective, I don't think we're missing out on much because whether what US does or not, right? Like the counterpoint is China is going to keep building without much concern around ESG.
Gotcha, gotcha. Maybe shift gears slightly. What trend with respect to AI and energy are you most sort of bullish on?
Um, I mean, there's a lot of trends, but I would say the agentic AI right now, and it's immensely powerful, but it's in a very early stage. So I'm going to
You're
preface
right.
this by saying that capability and reliability is not the same thing, right? What I mean is like AI agents can do a lot, but it's not reliable as of today, right? Because they hallucinate. There's like these things called handoffs. So multiple agents kind of do the job together. There's an orchestrator. They kind of talk to each other and then they kind of reconcile. Now, there's certain use cases where these agents are good because the hallucination doesn't have a big impact on decision making capability. So, good example would be like, hey, I'm not going to switch off my on and off my power plant based on what an agent tells me. Like, no operator is ever going to buy
Sure,
into.
sure,
But if you have a ton of ISO data or regulatory data that's coming in, which is insane right now, like parsing through that, or new siting docs from AER, for example, for Alberta folks, and in ERCOT, like all the reg changes like SB6, then DRS, like PJM coming up, then FERC puts up a new mandate to say that you must co-locate and make a new category for that. Like that's a lot of data parsing and trying to figure out what that means for your company. Now that's a good area. So from a trend perspective, I think that's where I'm seeing most amount of potential growth. And everybody wants to do it. Now, that being said, you also have to kind of, and we could talk about this later, but there's certain things that you don't need AI at all for. And like I think people are coming to a normalization where before it was just like ChatGPT AI is going to solve our problems, but now that is kind of normalizing, and it's okay. They're saying, okay, it's not the holy grail.
gotcha. Good point. Good point. What is one trend that's overhyped?
Oh, there's so
That's
many.
plenty. That's plenty.
I mean, I think the biggest one is I'm just trying to figure out. Like, there's like three or four that is going through my head. I would say the overhype is automation, right? Where people have been told that AI is going to automate like your workforce. In the energy, nothing could be further from the truth because again, like I said, that tribal knowledge that you have of asset operators, everything from midstream to refineries to oil and gas, Like, people who are doing like drilling, right? Or refining, even like power plants, man. Like a lot of these plant operators, reliability engineers, process engineers, like they grow up in those fields with their kids and their families, a lot of them. And so even like especially plant managers, right?
Uh-huh.
And so how to automate them is not going to happen. Even in finance, even in like there's so much travel knowledge that understands this now. But coaching folks to kind of come to that reality that this is not going to automate your workforce is something that people are going to have to feel it out, because what they're going to do is like, here's another good example. People thought that coding was going to be the most automated thing that's possible, right?
Yeah.
And now what you're doing is like a whole bunch of vibe coding is being done, which is the idea that you just prompt and build an application, but you get all this tech debt that you didn't want, and then you can't sustain it. So yeah, when you go live, it works. But when it breaks, you need proper engineers to come in and fix that thing. Because what's your alternative? You're going to give the entire code base to another AI model to fix that mistake. And guess what it's going to do?
Yeah.
It's going to fix that, but it's probably going to change a whole bunch of two or three other things, right? And so there's that trend also happening where people are thought that you could do a lot of citizen production grade development. And that hype is also kind of like downward because of all the pain points people have felt in the last 12 months.
Yeah. Vibe coding is a real thing though, right? Because in the hearts of a good engineer, yes. Right?
Exactly.
In the hands of a novice, it's dangerous. I agree with you. Right?
Yeah.
In terms of accelerating the productivity, in terms of technically savvy people, right? Like I'm one of those guys where I grew up in technology, but I don't code anymore, right?
Mhm.
And I'm not coded in a very long time. But vibe coding appeals to me because I have the foundation, I have the
Yeah.
fundamentals, right? So I can make decisions as opposed to someone who is not, right? And
Mhm.
someone who's just using vibe coding just to spit out something, right? Yeah. So
Yeah.
completely get that.
If you
Completely
if you
get
if
that.
you have your first principles, Swaroop, you're totally
Yeah,
right. Whoa, you're supercharged. Like I know folks who have not, just like
exactly.
yourself, who are decision makers who haven't coded in 10 years, but their foundation is there, so they know exactly what to call. I mean, Satya Nadella himself was talking about how he's like vibe coding now, right? And he's the
Yeah,
CEO.
true, true, true.
Sundar Pichai is also doing it on Gemini. They're all talking about it. So you're totally right. Like, if your foundation is there, it's vibe coding is a real thing.
Yeah, yeah. Supercharging is the right word for it. Exactly. Supercharging is the right word. Faster, simpler, easier to do, but you still
Exactly.
get a good output. Okay. And now let's talk a little bit about how fast utilities are generally adopting AI. This industry is always N minus something, not the fast movers yet. Are you seeing that trend changing a little bit? And is it going beyond pilots?
Yeah. In utilities, I would say yes, adoption is there, but depends on which business unit you're talking about.
Uh-huh.
So if you go towards legal, commercial, yes, they are adopting it at a pace that has even surprised me, especially like trading. And
Understood.
I think because like a lot of the utilities, not even just utilities, people who have exposure to power and gas spec books, right? Spec shops, they've always had an analytical mind, right? An analytical approach, because every cent, everything that matters quite significantly. So they've always been like tech friendly. And so adoption has been actually pretty rapid on that side. Now, if you go on the other side, and this is understandable, on the physical side of the ops operations, in that case, it's not. And the reason is it's completely understandable, like deployment on edge or deployment on telling how operators should be behaving based on AI outputs, that is immensely challenging, because you have to kind of walk people through the process of how did the AI come to the conclusion that my asset is suboptimal and has a 3% degradation or 4% degradation. And that requires a more elaborate change management process and a discovery process to kind of walk them through the process and then get them sold on it. So like, here's a very good example, right? Like I was working with a client working on a power plant. And so we just had to just let the algo run for 6 months.
Uh-huh.
And it was predicting like, performance degradation and telling them where the issues might be. And then sure enough, a Six Sigma event happened and the power actually plant tripped offline, and it was a force majeure. Now, when it happened in force majeure, after they fixed it, everything, they were like, hey, by the way, that model, like, did it pick it up? And there was a back test, but it was a back test on a live, something that actually happened. And the model actually had been predicting the degradation factor for some time. It's just that nobody was looking at it after the first 3 months, right? But then because of this trip happened and there was an investigation, they said there's a tool that might have done this. That's when they actually got completely bought in. And then that's when they started using it perhaps more engagingly and more interested in the tool. And then what they did was actually they helped me build it even better. because they were like, hey, how about this functionality? How about this functionality? And then you kind of manage it. But that side of the business, because it's the physical nature and it's completely understandable, takes a little bit more of an investment.
Good point. How about scaling beyond just the initial stages of the pilot? Are we seeing what are the challenges involved in scaling, according to you?
Yeah, I mean, it's very technical, right? So there's this thing called MLOps,
Yeah.
which is basically operationalization of machine learning models. So the typical problem right now is a lot of data scientists that are embedded in the business, or even like on the IT and IS side, they build a model. The problem is that when it goes live, you have to integrate it with a lot of your source systems, which is
Yeah.
an art on its own, right?
True.
And then what happens is that here's a very good example. A lot of these assets, power plants, midstream assets, compressor stations, even like, refineries, they basically have like a manual outage, and they replace parts. Now, one of the problems is that when you replace it, if that sensor was paramount for the model's accuracy, well, there has to be a ticketing system that notifies the developer that, hey, listen, this thing's been running for 5 or 6 months, but we replaced this part, so you need to go and upgrade the model. And so what happens suddenly, and you've seen it, like I've seen it so many times now, and nobody actually does this, and the model just like completely goes wacko. And then people go like, oh my God, something's wrong. And then after you do like months of investigation, you find out, oh, by the way, the problem actually was that somebody changed this part. So like it's those little things that make a huge amount of difference. And then the other part is like these models drift. So there's types of drifts that happen. A popular one is concept drift. And so what you're trying to optimize for, the target variable, might start going the other way. And you have to figure out, is it the problem what we're trying to predict that has started drifting, or is it the stuff that features that we fed into the model that has been drifting? And so that also is an art. So a very good analogy that I give to people is like, when you build a Power BI model, right? Like a Power BI or a Tableau dashboard visualization, it's a path of known, which is that once you get it working, something breaks, you see it on there, you know where the problem is, you go fix it. It's not rocket science, right? It's a playbook. Same thing with software engineering. Problem with AI is that it's an R&D activity. And even when you start going live, it's still an R&D activity because you don't know how the model will start behaving after the fact. And this is why, that last mile problem is significantly hard to kind of optimize for. It's very technical.
You're absolutely right. And beyond the technicality too, right? Like one of the fundamental things that I find difficult is the quality of data that you have, right? Because AI relies on data to train properly and to produce good results. And without fixing some of the data, if you go into a pilot might give you good results, but then your expectations are completely off, right? And then you get into production, you're a bit underwhelmed, and then this just sort of fizzles out. What people don't realize is you can fix data with AI agents too now, right? It's a matter of training an agent to be able to fix your data, using that agent again to report on most critical pieces of data, getting to some measurement of data quality. All of that is possible now with AI so differently than what it was possible earlier, right? And the force multiplier comes in there, and your ability to fix more and more. So people need to spend enough time in looking at the data, making sure that the quality is there, take steps to fix it, and then think about scaling, right? And sort of and define practical business goals. And I don't see that coming out too. So again, different people are different at spectrums of this decision-making process. I do see some clients are much more educated and understanding about this, but some others are not, right? So that's where the conversation is ongoing as well.
100%.
I did have a glitch with my camera. I don't know whether you noticed. I went away for a little bit, came back, and then just I don't know what, my camera is malfunctioning.
That's okay.
Need more expensive pieces of equipment. That's what it tells me. All right. Let's see what talk about like the human in the loop sort of scenarios in actually developing and deploying AI systems. The one theory is that you could train the systems and let it do what it needs to do. The other theory is you have to always have a human in the loop. The last mile has to be always a human making the decision to do it. Is that true? Is that true for all use cases? Or is it use case specific? And is it going to change in the future? Right? One of the significant aspects of it is agents can they make decisions and actually apply those decisions directly without a human in the loop? How some might argue we are a bit more away from getting there, but What do you see as a trend? Like, what's your gut feel?
I think the gut feel is what's playing out actually is everybody wants this functionality of an agent called set and forget,
Hmm.
right?
Yeah.
And so essentially the idea over here is how do we maintain an AI agent? So agents and agentic AI, they're a little bit kind of used together, but they're not the same. Agents, if you give them a one task, is because it's going to do that one task, right? And agentic AI, multiple agents kind of talk to each other and there's a feedback mechanism. Those things actually have immense complexities to it because the more they're talking to it, the more the probability of hallucination. Because there's a lot of context that's being shifted between these agents over and over again. And by the time it gets to the final agent, even if you have an orchestrated model, um, the decision model that's the decision agent that's going to come in might not have all the relevant information that it needs. So architecting that agentic framework is absolutely very critical because you have to, and then what is the use case, like you said, right?
Yeah.
Now, from the if you really want to talk about the agents, there's these three pillars for it that you need. It needs to be isolated, it needs to be portable, and it needs to be fully observable. Now, out of them, it all depends where your use case is going to be, right? And so to kind of like provide you a general framework, the idea here is for the human in the loop. I don't think about it like a human in the loop. What I call it is human in the end and human in the beginning. That's it. The amount of work that an AI agentic framework does or agents do is context dependent on your use case. So, for example, if you are building a trading application and it's going to tell you what trades to make or what bid ask spreads to do, for example, you can give it a little bit more because it's just a recommendation agent. It's not actioning
Yeah.
anything.
Yeah.
So, that human in the end and the beginning is actually quite limited, right? Because it doesn't have to do much. But in the middle, the agents are doing and going and like basically pulling all the market information, working with like the exchange data that's coming in the real time, working with your trading risk management tools, right? And then coming up with that framework. And this is actually being done right now. Now, when it comes to one of the asks that I get from a lot of the decision makers is like, hey, can we just like get agents to do a paper trade, but they're doing execution? I'm like, yeah, you can do that. Paper trading is, you don't really have any skin in the game and you're learning it, but how they might behave in the real world by doing actual executions might not be a good copy of paper trade because they're, we call them stochastic parrots, right? Like they're non-deterministic. You can ask the same question two or three times, you're never going to get the same answer. So QA becomes very hard for this quality assurance because now you're kind of going like, what added a complexity. Now, what happened in this paper trading environment, I wanted to execute as well. And then you kind of go like, oh, it didn't do what it was doing in paper trading. Well, yeah, no kidding, because these are black boxes. You can. And in that, in that framework, you have to figure out like in that, do I even want AI agent to execute a trade?
Yeah. Yeah.
And the idea and the ground rule, at least in all the deployments that I'm doing, is like, hell no. You're not getting that capability because your P&L is going to blow out from one or two bad trades unless you're Google DeepMind, who has all the reinforcement learning experts.
Yeah.
Don't do it.
Yeah. Gotcha. Gotcha. Where do you place reliability versus sort of accuracy in the spectrum, right? Like those are not the same things, right? When it comes to AI agents, what do we prioritize? Do we prioritize reliability or do we prioritize accuracy? And is it dependent on use cases, right? Like sometimes it
It
could be
all
dependent on
you
use.
nailed it, right? Like it's all depends on use cases. A very good example is, in the trading world, a lot of folks, like again, I have to be very careful. Strategies like hedge funds and
Yeah.
spec shops,
Yeah.
they're okay working with complicated neural network models, for example, because they have a bigger risk portfolio, they have a bigger risk profile, and they are in the world of this trading, right? And so in that world, they want accuracy, right? They don't care about reliability as much because they're literally in their VAR value at risk models, right? And the COVAR models, they're kind of running in that box and they're tuned. And they also have quants that kind of manage this. Now, if you go to the fizz world, right, the utilities world and trading shops, they are more averse to risk. They want decision trees, right? Which is simple. And the reason is because it has explainability to back up. So when your VAR explodes and the risk team comes knocking in, they would prefer to be like, okay, it's less accurate. It's not a neural net. It's not a deep learning model, but it's reliable and explainable, right? And that's kind of like how, as a concrete example, I can explain like how the world operates in this world.
Catch you. Good point. How about governance? You know, tied to that, what uncomfortable questions should leaders be asking about AI governance in utilities?
I mean, so I've done like what, 7 or 8 board presentations in the last 12, maybe 14 months.
Yeah.
And the uncomfortable question I ask them is like, Are you training the right people in your company who are AI forward? Or are you, blocking them off because of too many AI governance concerns? Or are you outsourcing a lot of it? And all of them have right or wrong answers. It's totally fine. My preferred model is that you basically enable as many subject matter experts in your company with AI. And that doesn't have to go towards like building AI models, right? It can just be like using Gen AI and agentic AI frameworks, like you're saying, to test it out. And I think that's where a lot of folks are kind of coming in. They're like, you know what? Like, you actually can level up your own folks inside who have the depth of knowledge, and they can actually do this last mile problem of actually like building. Now, I got to manage that and preface this by saying building POCs with agentic frameworks is one thing. Building sustainable solutions and scalable production grade systems is a totally different problem, right? And production grade systems are very hard. But if you take a hybrid approach where you say, listen, we're going to go enable our people to build all this stuff, what happens is like then they know that their proof of concept actually has a tangible ROI to it. And that's the home run, because now when you have spoken for that ROI, now you can build a production grade system. And before you couldn't do any of this, right? Like you only had limited bandwidth, you only had limited budget, and you could only do one or two problems at a time. Now you can do 6 or 7 in parallel, and then maybe your hit rate goes up to 2. And then you basically say, okay, now here's a production grade system, and this is how we work towards it.
If we were to be going into a new utility, never experiment with AI, right? They're wanting to start with something. What will be your top advice be, like sequence of steps?
I would say, don't use ChatGPT to do the job. you know Use it to learn the job. It's
Yeah.
immensely powerful. Like any AI model that that you're working with, one of the core things that I've seen across the board with everybody is that, like, for example, a lot of is being written with ChatGPT, and when things break and you ask, fundamental questions like, what does those 3 lines of code do, it's pretty hard for people to explain it who built
Yeah.
it, right?
Yeah.
And so one of the feedback that I give is like, it's not that rocket science. Like, when you build it, just literally ask ChatGPT to explain line by line what that code is,
Yeah.
right? So that's one. The second one I would say is, build blogs, Substacks, and everything, social media, conceptually, theoretically. Yeah, it's great, but it's never been a better time to just go cook up a book and start, building a use case. And you'll be surprised how much you learn over that and how easy it is in today's world. So that, I think those are the two things. And then that has a compounding effect of ability to, like, build more complicated systems.
Great. Awesome. You spend a lot of time across the US and Canada, right? Like Canada is where you live, but US is where a lot of the work happens. Two countries, very similar, but not so much anymore in terms of ambitions, in terms of what we're trying to do, etc. What is your advice to Canadians, if any, based on what you see down in the US?
I mean, I think I think Canada has an immense advantage of how much good talent that we create here, right?
Yeah,
If you look at
a
area.
lot of it gets exported to the US right now.
Exactly, exactly. And now that, here's a very simple trend that I've seen. If you go to Toronto and you go and ask, Waterloo students or Queen students or Toronto students, I'm like, what are you going to do? They go like, oh, I want to work for Google, or, because
Yeah,
they're the hubs
yeah,
there. I
yeah.
want to build some stuff. And it's almost like if you go to comp sci, software engineering, STEM programs, that's kind of like, or banks,
Sure,
right? That's what it is.
sure.
But they all want to work for a US company, like a big one, or the banks, etc. Now, if you go down to states, what the trend that I see is completely different, which is that 50% will still say, yeah, I want to work for Meta, I want to work for Google, I want to work for Access, etc. But the other 50% will say, I want to build something, right? And they'll say, like, I want to start a company. And so I think one of the fundamental questions we have to ask ourselves is like, why don't our entrepreneurs or young grads want to build something in Canada? And it's very paramount. You can see it. The second part is what you hit it out of the park, which is like, why are they leaving? And what can we do to keep them here? And the answer is very simple, right? Like, remove a lot of the red tape, create a very startup friendly environment. Because, like, all the top tier, when I go to Valley and I go to the meetups, like, in Palo Alto, if I go to Austin, I think 25% of them are Canadian, right? Um, and you can see, like, Ilya, the co-founder, one of the first engineers that Elon hired for OpenAI, Andre Karpathy also studied in the university, Jeffrey Hinton, other of reinforcement learning, Joe Sutton. They're all from here. So the talent is here. And we have created like top tier. They're just not building anything here. So I think for the Canadians, I think we need to like sit back and ask ourselves, like, what do we need to do to create an ecosystem where, these folks that are completely coming from our universities start building and starting, immense startups over here. And what do we do to kind of like start keeping those unicorn companies, going from one or two companies maybe to like maybe 10 or 15, because we have the capability.
Yeah, you hit the nail right on its head, right? It's we talk a lot about how much our export dependency is on the U.S., not just in terms of resources and other products, but not enough about our export dependency on the U.S. in terms of manpower, right? And how much we are losing there. And the answer is about making it business friendly here, right? Cutting regulations, making it easier for entrepreneurs to start something, fail, have that safety net, all of that. US has traditionally done a tremendous job of that, and they are reaping the benefits of it, and now using that as a leverage against everybody else, right? Yeah, exactly what I was expecting you to say, and thankfully we are on the same page. I think we pretty much close to the end of this, but I want to wrap up with anything that you wanted to specifically call out for our audience today.
I think
The big message, the big idea.
I think the big message is that, the AI team and the AI data centers, for the first time, for almost like 90 years,
Mm-hmm.
we didn't upgrade the grid. We didn't build much in North America. And for the first time in almost like 90, maybe even 100 years, we have this grand opportunity for tech companies who are begging us to upgrade our
Yeah.
grid,
Yeah.
and they're paying for it.
Yeah.
Right? A lot of these companies are not even raising debt. They have cash to deploy. For the first time, they have the ability to like really go into infrastructure spend for something that's very tangible. And there is no such thing as like, having immense amount of energy surplus is in a better spot than being on an energy deficit. And so if we have the capability to use the molecules that North America is blessed with two oceans on each side,
Yeah.
utilize them
Yeah.
to generate electrons that is then going to generate intelligence, right? Compressed cognition is what I call it,
Yeah.
for the price of a $30 subscription. I think that's a home run for civilization, right? And so I think there's a positive spin to the story of AI data centers, because there's a lot of negative limelight given to it. But I think downstream effects, right? Like you can today pretty much copy paste a doctor and a programmer onto a $30 license. That was never possible with the internet invention or the electricity invention, the steam invention. It was fairly like it was a different world. But in today's world, you have this on your phone. You can take a video, and me and you were talking about it, right? Like how we can just take a video and talk to an agent or an AI model and be like, "Can you help me fix my car or my furnace," for example. And so there is a very good side of the story, which is people, I found, from teachers who are struggling to, with expanding classrooms, to use AI, cheap AI, to basically teach students who are, some are visual learners, some are auditory learners. For same $30 subscription, you can take the same content for teaching, put it into an LLM model, and generate a video out of it, or a PowerPoint slide deck today, right? And the same thing happens with mechanics, right? Like teaching your kids something that you don't understand in math. Like this is all possible because of these AI data centers. So I think we should really invest ourselves into the idea that we need to invest in our infrastructure stream, and downstream, and then power in electrons so that we can have this capability of a $30 subscription.
Yeah, and I'm glad to see that there has been some movement on that, and I'm pretty sure you would agree with it, right? The recent announcement in MOU, everybody was keeps talking about the pipelines, but the other big news in that was like the ability to now build gas-fired generation for AI data centers, right? It was a big thing. I don't know, the Capital Power CEO, Avik Day, talks about it quite a bit, and he highlighted it a couple of times. But people are so focused on the pipeline question, which is important too, by the way, that they forget the fact that there's an important win there as well. Anyways,
You got it.
it's a great positive note to end our podcast. What we have about 50 minutes of content that we need to sift through, but I enjoyed talking to you, Wish, and all the best with everything that you're doing. I'll pretty sure we'll catch up soon.
No, I appreciate that. And keep doing you. We need more of this to get the word out. And there's not enough content that you can generate, Swaroop, that is
Yeah.
enough for the audience. So keep doing you. I wish more folks were doing it, but you're doing God's work.
Thank you. Appreciate that.
All right, you take care.
All right.